249. And we've done so far, we've looked at exponential graphs. We just looked at the two graphs. So the first graph was your base graph, y equals 2x. And then we had the four characteristics. And then you, in the second section, was doing all the transformations. So doing your standard y equals a, x, b, x minus, or sorry, this is a base. Base c, x minus c add d, right? So in which a changes your amplitude, how fast it goes up, okay? B is the change in the x values, divided by a factor of b. C is your transformation right, and d is your up and down, okay? So that's all we've done up to this point. Now what we're going to do, okay, is look at solving these questions, first with a common base, and then second without a common base. How does it work? Okay, so for example, if I have this here, how do we solve for x in this case when x is part of the exponent? All right, well, if the left side equals the right side, and the bases are exactly the same, so what does that mean for your exponents? If they're equal on both sides, and the bases are the same, what do your exponents have to be? The same. They have to be the same, right? So therefore, this 2x plus 6 has to equal 2, correct? And then we just solve for it. Subtract 4, or subtract 6, I mean. Get negative 4. X is equal to 2, right? Okay? So one of the procedures, one of the things that you want to do is you want to try and get the bases to be the same. Because if you get the bases the same, then the exponents have to be the same. So another example of this would be 9x plus 3 equals 81. 2x plus 9. All right. So right now the bases aren't the same, right? Okay, so somehow we want to get the bases so that they're the same, if we can. And if we can, then what we're going to do is we're going to work with the exponents at that point. So is there a way in which I can get a common base between 9 and 81? 3 I could use, for sure. But there's actually a simpler one than that. 9, right? So I'm going to leave this base as 9 here. So I get 9 to the x plus 3, right? Equals, what is 81 written as a base 9? It's 9 squared. So I have 9 squared to the 2x add 9, correct? And what do I do when I have an exponent to the exponent? What do I do with the exponents? That's right, all right. So now, at this point, let's refresh. Okay, this was grade 10. Starting with this. What do we do with the exponents? You have a common base and you multiply them, we add them, right? So we have that. Now this is important because when we do logarithms, which is the next unit, we need to know all of these very well. So what do we do with this one? Subtract the exponents, right? Multiply them, good. So far so good. Okay. The 0, any value, the base 0 equals 1. So far so good, right? Okay, so those are the 4 base ones. I think there's about 2 more that we'll have to look at, but these exponent laws are going to be important to us when we start looking at Unit 8. Okay, on logarithms. So let's go back to this question now. So what do? I have an exponent to an exponent. What do I do with it? Multiply it. So I have 9x plus 3 is equal to 9 4x plus 18. Right? Now I let them equal each other and I solve. So I have that. Okay? I'm going to subtract 18 to this side. Subtract x to this side. And then divide by 3. Okay? And you should always plug it in to make sure it's correct. Right? So I would put minus 5 in here That would give me 9 to the minus 2. What is 9 to the minus 2? There's the other rule. Let's do that. There's the other rule I forgot about. A to the negative y. How do I make that exponent positive?
Put it under 1.
Put it under 1, the whole thing, right? So it's 1 over, let's see, a to the y. So there's your fifth rule, okay? So then, when I had it up here, I had 9 to the negative 2, which is like 1 over 9 squared, which would be 1 over 81. And then when I do that here. Now, Ty did say we could have made them both 3's as well. 81 is 3 to the 4th, 9 is 3 squared, and you could have worked with them because the bases still would have been the same. All right, but the easier way to do this one was to do them as 9's. Okay, so far? All right, so okay, and again, this goes back to what we did in grade 10 and 11. So what's new? What do we need to know how to do that we don't already know? And that is this. That there. Okay, so what do I do in this case here? 1.4 is equal to 7 to the x. But it doesn't matter. I'm not too worried about it. It's going to work out the same way. Okay, so 1.4 equals 7 to the x. Can I get the same base? Can I get a common base here? Is there any way I can change 1.4 to be a base 7, or is there any way I can change 7 to a base of 1.4? The answer is no. Okay, there's no way you can't do it in the current form it's in. Okay, so then what do I do? Well, what do I do when I have polynomials on both sides and I'm not sure how to simplify them? What do I do when I have trig functions on two sides and I don't know how to simplify them?
Move them on the same side?
You can move them all to the same side. That absolutely would be a suggestion here. So let's just do that just first. This is not the way I would solve this question, okay? But I like it, all right, because we're used to it. So now, that would be 0 is equal to 7 to the x minus 1.4, right? Okay, so what do I do if the base graph is 7 to the x? Which way does it now move? If I change this, yeah, you're right, to that, I take my base graph, which is y equals 7 to the x, which crosses at 0 and 1, right? Now which way does it move?
Down.
It moves down 1.4. Okay, so now, just a refresher, because you haven't been to school for almost 5 days, all right? What does that make the y asymptote then? What does the y asymptote equal? What's the equation of it? Y equals negative 1.4. Y equals minus 1.4, right? Because your standard graph would look like this, right? 7 to the x, here and here, correct? Goes through there. My asymptote is right there on my standard graph. And where did I move the whole graph? Down 1.4, correct? So this line here comes down to right there. Okay, so then what would your range be? So let's refresh again. My range would be what? Y is greater than negative 1.4. Correct? Okay? My good math skills, what would my y-intercept be? Pardon me? Negative 0.4. Well done. 1 subtract 1.4, right? You move that 0 and 1 down, 1.4, so these are 1.4. What's the domain? Doesn't change, does it? Okay, so absolutely, Cody. Move it all to one side, and then graph that. Okay, so what would I be looking for to find out in this case? If I did this, what am I looking for on the graph to find the answer, to find the solution? What part of the graph tells me what x needs to be? What part of it? Well, what does y equal? What does y equal right now? With the way I've written the equation, what does y equal? What is it? 0. When y is 0, what am I finding? The x-intercept, right? So what am I looking for? The 0 right there. So when I place everything to one side, I'm now using my calculator to find the 0 in this question here, right? And that's perfectly legit. We've done that for parabolas, we've done that for trig graphs, we've done that for polynomial graphs, right? It's all good. So that's one way to do it. So what's the second way in which we could have done this question then? I started the question with 1.4 equals 7 to the x, right? What's the second way in which I would have done this question? What do I do? Yeah, absolutely. Okay? y1 7 to the x. y2 equals 1.4. And then what am I finding to get my x? The intersection. Right there. So, same solution for both. Okay, if you like doing it this way, graphing the whole thing and just finding your 0, perfect. If you just as soon graph y1 equals 7 to the x and y equals 1.4, also good. Both ways will give it to you. And both are just the same thing, second function trace or calculate, right? And the 0 or the intersection point is found in there. Okay? So these are used, why are we doing this? This is totally used for a question in which our bases are not equal to each other. Because we don't have another way in which we can solve it if our bases don't equal each other. Got it? Okay. Any questions about this? This is all calculator again. Except for if you actually look at, go to page 250. And what they want you to do on 250 is they want you to practice your skills, mostly mental math for the record. Don't be using a calculator for this. And changing your bases. So the first thing says, rewrite each of the following with a base 2. So how do I write 32 as a base 2? So in other words, I'm saying to you, okay, 2 to the power of what gives me 32? That's what I'm asking you. Okay, anybody got an answer? 6? 2 to the 6? Okay. 2 times 2? 2 times 2 is what? 4. Times 2 is?
8.
Times 2 is?
13.
Times 2 is? 2 to the 6. Okay? One more grade 10 piece of information that Kelsey had forgotten this morning when she worked with me. And that is this. How do I rewrite this as a base 2 with an exponent, with one single exponent? Okay? So the first thing, my first question to you is this. All right? How do I write the cube root as an exponent? Oh, light bulb went off. Yes, that a girl. Okay? One of us remembers. So how do I write any root as an exponent? You write it as a fraction. Correct? So 16 to the 1/3. Okay? But I need it in base 2. So what is 16 to the power of 2 to the power of? 2 to the power of what gives me 16? 4. 2 to the 4 to the 1/3. And what do I do with an exponent to an exponent? Multiply. 2 to the 4/3. So again, stuff that we did in grade 10, a little bit in grade 11, but mostly grade 10. So that's that. Okay? And remember your rules, especially these guys down here. This guy down here we use quite a bit. Changing fractions. All right, so moving them above the line by changing them to make them negatives, or below the line, or just switching them top to bottom just to make them positives, okay? And that pretty much does it for 7.1. 7.3, sorry.